Hmm. Welcome to another video episode consisting of a numerical problem which comes under current electricity for NCERT 12th standard. So let's get into the problem. If a copper wire is stretched to make it 0.1% longer, what is the percentage change in resistance? Okay, so a copper wire, let us assume that this is a copper wire. This copper wire, they are elongating this copper wire to a small length. That length is given in percentage as 0.1 percentage. It is given as 0.1 percentage of elongation is applied to the initial length of this copper wire. So that is what they are asking. So now we need to find the percentage change in resistance. We need to find the percentage change in resistance. Okay. So what are we supposed to do? We know this formula. We know the formula for this one as specific resistance R equal to rho into L divided by A. Right. So now what I'm going to do is, now with this formula, I'm going to multiply and divide by L. I'm going to multiply this quantity with L and this quantity in the denominator with L, so that even though I multiply by into L divided by L, my value won't change. This OL by A won't change. Okay, so multiply numerator and denominator by the length L. So if I multiply, it will be rho into L squared divided by A into L. Okay, so rho into L squared divided by A into L. What is A into L? Area into length. Product of area into length is volume. So I am denoting it with V, capital V. So this V is volume. So in this one, the volume won't change. The specific resistance of the material won't change. While the copper wire, this is the copper wire, when I elongate the copper wire to a small distance dx, for example, let us assume that x is the length of this copper wire, and if I happen to elongate this wire through a length dx, the specific resistance, the value of the specific resistance of this copper wire will not change. And another thing is that the volume remains constant, so there won't be any change in the volume. So rho and v remains same, but only the length will change. Obviously the length will change because we are applying a force in the longitudinal direction, so that the linear dimension, there is a change in the linear dimension. So this x is converted into x plus dx, so there is a change in length, so there will be change in length, L will change. So let us assume that for time being we'll erase this diagram. So we have obtained, let us assume that R equal to rho L squared by V as equation number 1. Okay, so similarly what we need to do is, so we have got R equal to rho into L squared by V. R equal to rho into L squared divided by V. So this is equation number 1. Now I'm going to differentiate this equation 1. Okay, so what I'm going to do is differentiating R with respect to L. Okay, so what will happen is, when I differentiate R with respect to L, I'll be getting dr equal to rho by V is a constant because the specific resistance of the material won't change. The volume of the material also won't change. So rho by V, I am taking it outside as constant, and L squared is there, which consequently will change because there is an increase in the linear dimension. So L squared, if I differentiate L squared, it will be 2L into dl. 2L into dl. Right? So this I am naming it as equation number 2. Now what I'm going to do is, I'm going to divide equation 2 by equation 1. So if I divide equation 2 divided by equation 1, I'll be getting as dr divided by R equal to this rho by v gets cancelled. Okay, so I'll be getting 2L into DL divided by L squared. 2L into DL divided by L squared. So now L gets cancelled. So I am left out with 2 into DL divided by L. So therefore dr by r equal to 2 into dl divided by L. Right. Now we have obtained dr by r equal to 2 into dl divided by L. So now what I'm going to do is they are asking us to find what is the percentage change in resistance. So for percentage we need to multiply it with 100. So dr by r, dr divided by r into 100. I'm going to multiply with 100 on both the sides, both the left hand side as well as the right hand side. Dr by r into 100 is equal to 2 into dl by L into 100. So dr by r into 100 is equal to 2 into dl by L into 100. So what is the value of dl by L into 100? We know that is 0.1% longer. So dl by L, the change in length. Okay, the change in length, that is the elongation. The elongation is nothing but dl by L. Okay, so if this is the length, for example, if this is the length of the copper wire, there is an elongation, and that elongation is nothing but dl. So dl by L is nothing but it is the change in length. Okay, the change in length, that is dl by L. For dl by L, the change in length, there won't be any units because dl measured in meters, this length is also measured in meters. Meter get cancelled. So it's a dimensionless quantity. So dl by L. So dl by L is nothing but 0.1. So they are expressing it in percentage. So dl by L into 100. For dl by L into 100, I am substituting this value 0.1. So which is nothing but 2 into dl by L into 100 is 0.1, which is 0.1, right? 0.1%. So which is 0.2 percentage, right? So this is the value. So what is the final value? What is the percentage change in resistance? Therefore, the percentage change in resistance is nothing but 0.2. Or you can say 0.2 percentage. That is dr by r into 100 is 0.2. This percentage should not come. So it will be the value of dl by L into 100 is just 0.1. So 2 into 0.1 is nothing but 0.2. So dr by r into 100, which is nothing but the percentage change in resistance, is 0.2. Right? Thank you guys.